All right, everybody, I wanted to work out the first practice test that I gave you this week, and I'll be working out the second practice test as well, or at least posting solutions. So I provide you all the formulas that you got for the last exam. I'm also providing new formulas. So I think one small thing I should change in this formula sheet right here is on the vector formulas, please note that the angle theta is right here. It's between the vector and the x-axis. So very badly drawn theta. Let's try that again. There we go. There's the angle theta. We have our projectile motion equations for both horizontal projectile motion and full projectile, where the thing actually covers a parabola. So with this in mind, we're going to jump in and get started on the exam. So problem number one, it says, please answer the questions about the graph below. So which object is going faster? The answer to that is object B, and we know that because the slope is steeper. Okay, the next question. We want to prove our answer by getting the velocity of each object. Now, I'm going to be a little more careful here than I see some of you being. So I'm going to actually go ahead and label the points and use the slope calculation. I see a lot of you counting squares. That's fine, but square counting is not always as accurate as using the formula. So here I'm at 0.16, and here I'm at 3.10. So let's get that slope. That's going to be, for object B, the velocity of object B is going to be its rise over its run, so that's going to be 10 minus 16 over 3 minus 0, and that's going to end up giving me -2 meters per second. Similarly for object A, let's go ahead and do its calculation. So the velocity of object A, let's label those points. So we have this point 4, 6, so at 4 seconds it's at the 6 meter mark. And when we first start the stopwatch, it's at the centimeter mark, not meter. So VA, let's get the rise over the run. That's going to be 6 minus 10 over 4 minus 0. So that's going to be -4 over 4, which is going to give us -1 meters per second. All right, similarly, they ask us for the displacement of each object after 2 seconds. And what a lot of people were doing, I'll show you. I'm going to do this actually in a different color. So at 2 seconds, I see that the coordinate is 212 for object B, and what that means is that at 2 seconds, it's at the 12 centimeter mark. For object A, at the 2 second mark on the watch, it's at the 8 centimeter mark on the ruler. So let's be clear, displacement is the change in position. So for object B, I'll just do that one first. So for object B, its displacement is going to be 12 minus 16, which is -4. Because let's remember, even from our formulas, displacement right here is the final position minus the initial position. So please be careful on that. And then for object A, using very similar math, for object A, it ends up at 8, having started at the 10 centimeter mark, so its displacement is -2 centimeters. And let me just add units to B right here. All right, now it says, please plot the velocity of each object in the graph below. Let's go ahead and do that now. So the velocity of object B is going to be 2, actually -2, sorry about that. And because we're just plotting the slope is the velocity, so we just plot a flat line that represents the slope. And then for object A, the slope is -1, so that means the velocity is -1. So that's what we plot right there. Excellent. So that is problem number 1. We'll do problem number 2 in the next video.